Hello guys, welcome back to another video. When people first start with natural language processing, one of the things that they inevitably encounter is to find some high-quality data to practice. Luckily, YouTube has provided an API for people to download data from it. You can easily find resources that teach you exactly how to download YouTube comments from YouTube API. Now, let's say you want to separate YouTube comments from the replies to those comments in your downloads. This would be the video for you. Without further ado, let's jump to our Python code. In the first cell, we have 5 imports. The first one is Pandas, the most widely used library for data analysis and manipulation in Python. If you have done some data analysis in Python before, I am pretty sure you have come across Pandas. If not, it doesn't matter because you can easily find resources that teach people how to use Pandas. The second library we import here is PPrint. PPrint allows us to view JSON files in a clear layout, and as we will see, data extracted from YouTube API are in JSON format. Here is a quick taste of what a properly formatted JSON looks like. This is an employee array in JSON format holding the names of 3 employees. And what PPrint does in Python is to give us all these nice indentations so that we can read JSON clearly. In our case, the YouTube comments data would look something like this, and we will come back to this. The third import allows us to use a very convenient function maintained by Google. This is the build function within the Google API client library, allowing us to connect to YouTube API with just one line of code. If you want to learn more about the Google API client libraries, you can check this out. Basically, Google built all these to make our lives easier. However, there's one thing we must get before connecting to YouTube API, which is the API key. Now I will go through the steps for obtaining an API key to access your YouTube API. First, we need to have a Gmail account, which most people would have. Then we need to go to the console.developers.google.com. I would paste the link in the description below. Here I have 2 accounts, and my bottom account still needs an API key, so I choose this one. If you have only one Gmail account, your screen will show only one account. Then here, this is the one that I need to get an API key. I now need to create a project and just click new project, give it a name, API key. Okay, great. Okay, now we have this project, and then we click this project, and then API and service, enabled API and services. And then we click this again. The one we are interested in is the YouTube Data API v3. This version 3 will be reflected in our Python code later, and you will see that. So we click this one. Click enable. Okay, now we click credential and then create credentials, and then click API key. Okay, now this is your API key. You copy it to your clipboard and then paste in whatever file you're comfortable with, and then close it. The fourth library we need to import is Configparser. Configparser allows us to load a password or API key from a file without typing it into our Python program directly.
Suppose this is the secret password we need to load into our program. What we need to do is to give our password a name. Here I call it my password, and also a header. Here I call it my session header. You can name the password and session header whatever you want. We then save this text file with a file name that ends with .cfg. Here I just call it test.cfg. Now we can upload this test.cfg file into the drive provided by Colab. Let's do this. Anything we upload here can be accessed by our Python program right here. Let's upload this test.cfg. Okay. The syntax of Configparser looks something like this. We first call the Configparser function from the Configparser library, and then store it into a variable called config. There's a built-in read file function that we can use to read this test.cfg into our Python program without showing the content of the password. We just need to specify the session header, which is here, and then the name of password. And with these two variables, we will be able to read the password. Here, we can just for the demo purpose, print the password from this test.cfg file. Let's do it. Okay, so our password is our secret password. And this shows that our Python program can read this password. After loading a password, we may want to keep it somewhere safe. This is where the OS library comes in handy, which allows us to store information as environment variables within the operating system. This can be useful when our program is designed to be accessed by other programs or machines. Now, to store our password in an environment variable, we use the mapping function environ and map our password to a newly created variable. Here, the variable is called our secret password in OS, but you can name it whatever you like. In practice, we would not print out a password in a program, but here we do it for demonstration. Okay, it works. Now, to see all the environment variables within the operating system, we can use os.environ again, and this time we got it as an enormous container with all variables inside it, and then print out all of them. Okay, let's do it. As you can see, our secret password in OS is one of the environment variables within the operating system. Okay. After discussing all these foundations, let's start getting our hands dirty. We first load our API key into Colab. Okay, let's do it. Okay, it would take a few seconds. And then run this. Here we are utilizing the build function, which we mentioned earlier, to make a connection to the YouTube API. So let's run this as well. Now, suppose we want to download the comments and replies in this video called How the Economic Machine Works. We go up to the URL and then double click at the end and then copy. This is basically the video ID of this YouTube video. And then we can paste it here and then run it. So basically this is making an API call to the YouTube API. Have a look at the response. Okay. You may wonder how I managed to get this piece of code to work in the first place. The answer is the YouTube Data API reference. If you are new to the YouTube Data API, quickly reading through the overview in the guide is the best place to start. This relatively easy read will save you much time and trouble when you implement your application using YouTube Data API. If we scroll down, this table tells us all the data resources we can extract from YouTube Data API and the standard methods we can apply to these resources. You may wonder what are the main differences between the comment and the comment thread resource. The comment resource has all these top-level comments and all these replies to a top-level comment. The comment thread resource, on the other hand, contains only the top-level comments and a few replies. For YouTube videos that have many replies, the majority would not exist in the comment thread. In our case, we would need to use this list method to return data from both comments and the comment thread resource. To get a view of how all this works, let's go to Reference and then click Comment Thread. Click List. We can now see this Try This Method user interface, which allows us to try the API without writing any code. We first need to tell YouTube Data API what information we need to extract. In our case, we just type ID snippet and replies. So ID refers to the unique identifier of a comment thread. Snippet contains the top-level comments and other basic details of a comment thread. Replies, on the other hand, contain only some replies to a top-level comment. As mentioned earlier, if we need to get all the replies, we would need to use the comment resource instead. Let's copy the video ID and then paste it here. Okay, we need to input this again and then uncheck the OAuth 2.0, click Execute. Here we go. We got some output from the API request. As mentioned before briefly, data returned from YouTube API is structured in JSON format. JSON is a hierarchical and nested collection of key value pairs. For example, under the key items, there are some other keys such as kind, etag, ID, snippet, and replies. Under the key replies, we've got comments. And then under the key comments, there are keys such as kind, etag, ID, snippet again. So, reading data from JSON is just a matter of looping through the keys until we get the specified piece of data we want. Okay, to find some sample code that we can adopt and use, we just need to click Show Code. Then, as we can see, YouTube has provided code templates for multiple languages. But in our case, let's choose Python. Okay, in our Python program, we need to tell the API a few things. First of all, we are interacting with YouTube rather than other services also provided by Google. Secondly, we need to use version 3. To see that, let's go back to the reference and then click Samples. We can see that we're currently at version 3. Okay. Thirdly, we are using an API key to connect. Then from the Google API client library, we use the build function to make a connection to the YouTube API using the parameters we just mentioned. So after establishing the connection, we can tell YouTube that we want to get some comment threads using the list method for this particular video. So basically, this is the code logic. Let's move back to our own code, which is an enhancement from this sample code here. First, we need to create some empty lists to store the data we need. The first one is original list, which will store only top-level or non-reply comments. Then we have original account ID for storing the Google account ID of the people who had left a top-level comment on a video. Original comment ID is for storing the unique ID of a top-level comment. Similarly, we have reply list for storing replies to top-level comments. Reply account ID for keeping the Google account ID of the people who left a reply. And then replied comment ID for the unique ID of a reply. The final empty list, reply original comment ID, stores the unique ID for a top-level comment to which a reply has been left. We need this information to determine which top-level comment a reply is associated with. To scrape the comments and replies of a YouTube video, we first need to specify the video ID of the video. This piece of code should look familiar to the sample code we have seen in the user interface earlier. Here, we are sending a request to the YouTube Data API and applying the list method to the comment thread resource. Here, the max result is the maximum number of comment threads to retrieve from an API request. We're setting it to 100, which is the maximum allowed. Okay? If we want to check this max result in the API reference, we can again go to Reference, Comment Threads, List. If we scroll down, we can see max results here, and the acceptable limit equals 100. Remember, the output from the YouTube API response is in JSON format. What we want to do is to make our program accurately loop through every single element in the output and store the information we need accordingly. To be able to do that, we first need to know the hierarchy of all key value pairs within our data. Let's take this text original as an example, which is the original text of a YouTube comment. To clearly see the hierarchy of all key value pairs, we can look at the response from our API request in the user interface earlier. So, before reaching text original, we need to find snippet. To get to snippet, we need to be at the top level comment. And before that, we need to reach another snippet up here, which is under items. So, as long as our program reflects the correct sequential order of all these key value pairs, we will get the data we need. So, after getting a response from the YouTube Data API, we would use a for loop to loop through every item in the response. The lang function returns the count of all items in the API response and therefore sets the upper boundary for the number of iterations that are allowed in the for loop. This range function, on the other hand, creates a sequence of integers starting from 0, with each subsequent integer being incremented by 1. the last integer in the sequence equals the count of all items minus 1. So the index will loop through every single integer generated by this range function and allow us to access every single item in the response sequentially. Okay?
Then we have this if statement to check whether the Google account ID of an author who wrote a comment is available, and would only keep the information of a top-level comment when the associated Google account ID exists.
Then the following 3 lines store 3 pieces of information from the API response. Original list is for storing the top-level comments, and this line will replace new line symbols, tabs, dashes, and consecutive white spaces. Original account ID will keep the Google account ID of those who wrote a top-level comment. Original comment ID will keep the comment ID of a top-level comment. Occasionally, we may have 1 or 2 cases where the returned data contain a comment but have an empty value in the Google account ID or comment ID. If that happens, our program will store no entry replacing those missing values. Okay? Let's scroll down a little bit. Now, this line of code checks if there are any replies to a particular top-level comment. If there's no reply, total reply count would be 0, and the program will skip this whole code block under this if statement. However, when there's a reply, this line of code will send another API request and retrieve data using the comment resource and the list method. Note that here we would need to specify the comment ID of a top-level comment to which a reply is associated, and we put it in the parent ID parameter. Remember that we use the same code snippet when storing the comment ID above. Okay, so this is how we connect to the API for downloading all the replies related to a top-level comment. Here we've got another for loop for storing the data of replies. Similar to the logic of the previous for loop explained earlier, this for loop will go through every single item in the response, and during the looping process, we will store 4 pieces of information. Reply list will keep the original text of replies. Again, this line will remove new line symbols, tabs, dashes, and consecutive white spaces. Reply account ID will keep the Google account ID of the person who wrote a reply. Reply original comment ID will keep the parent ID of a top-level comment associated with a reply. Reply comment ID will store the comment ID of a reply. Now, since only 100 replies maximum can be retrieved from each API request, the returned data would contain a next page token if more than 100 replies have been written under a top-level comment. To see what a next page token would look like, and to get a feel of how this comment resource works, we can use the user interface again. Let's go back to this video again and sort by top comments. We do this because we want to compare the data returned from API directly with all these replies we see here under this video. Okay? Again, we would copy the video ID and then go to the reference page, comment threads, list, and then in the try this method user interface, we paste the video ID, and then we would choose the relevance in the order option, simply because we have done the sort by top comments earlier. Okay, and then we would, as usual, input ID snippet and replies into this part parameter, uncheck OAuth 2.0, and then click execute. So we've got this comment, literally amazed at myself that etc etc. Let's verify this comment quickly in the video here. Literally amazed at myself that I was able to, which is the same top level comment. Basically, we will use the ID of this top level comment to extract the replies under this comment in the user interface. Okay, let's move back to our earlier results, which is this one, and then we copy the comment ID and go to the reference, comment, and then list. In the user interface, we paste the comment ID into the parent ID parameter. To show the next page token in the response later, we would enter a limited integer for the max result. Let's try 5. And then we would input snippet for the part, and then uncheck OAuth 2, click execute. So now we have 5 replies. Let's check the first one, the key thing to consider, etc. And then let's see if we find that in the video. Let's scroll down. Okay, the key thing to consider whenever, etc., which is the same reply we just saw in the response. Okay, scroll down, we see the next page token. We would copy this and then paste it here in the page token parameter, execute again. This time let's check the last comment, okay, which is the sage to be fair though consider is regular people that make, etc. Let's see if we can find this one. Okay, sage to be fair into consider is regular people that make the system run, which is the same reply we just saw in the result returned from the user interface. So hopefully now you can see the logic behind the next page token. Okay, let's scroll down a bit. Here the try statement is used for checking whether a next page token exists in the previous API request. If yes, the program will store the next page token into the variable page token replies and then execute the while loop below. Otherwise, this block of code will be skipped. So under this loop, the program will make another API request like what we manually did in the user interface earlier. Again, we are applying the list method to the comments resource. This time, in addition to the parent ID, we would also need to specify the next page token so that the API understands that we continue to retrieve data precisely from the end of a previous API request. Again, we have a for loop to loop through each item in the API response and store the information of replies that we need accordingly. When we reach the end of this code block, this while statement will check again whether there exists another next page token. If yes, this while loop will repeat and send another API request. Otherwise, the program will exit this while loop, meaning that the replies associated with a specified parent ID have all been extracted. Okay? The program will then proceed to this try statement. From the fact that there's no indentation here before the try statement, we can tell this next page token is related to the first API request code snippet up here that also has no indentation. Remember, top level comments come from the comment threads resource. If there are more than 100 top level comments in a video, the response from this API request will contain a next page token. So again, this try statement checks whether a next page token exists in the previous comment thread's API response. If not, the program will have completed its mission. However, if there exists a next page token, it will continue and execute this while loop using this next page token. If we have a quick look at the code under this while loop, you will see that this is the same as the code in the first half of this program. We just repeat what we have done so far, apart from the fact that we need to specify the next page token here in the API request. So again, we're sending the request and then trying to retrieve the comment thread using the list method. And once we got a response, we will loop through each item and store the top level comments, Google account ID, and also the comment ID. So again, if something is missing, we will fill it with no entry. Let's scroll down a bit. The same as what we have discussed about extracting the data of replies earlier, we would need to specify the parent ID of a top-level comment in the API request using the comment resource and the list method. We then have the for loop to loop through each item in the response. And then we would store 4 pieces of information related to the data of replies. We would then do a check on the next page token and make another API request for each next page token found. Then, as usual, we would store the 4 pieces of information that we need. So if all the next page tokens have been exhausted, we will reach the end of the program and should have downloaded all the comments and replies data from the YouTube API. After downloading the data, we can do a quick count to see if the total number of comments and replies is close to the official count that YouTube provides. Here, we count the number of records in each of the 7 Python lists that we used for storing data. The 3 lists related to top-level comments have the same number of records. The 4 lists related to replies also have the same number of records. That means our loops in the program are working as expected. At the end of this cell, we have a total count of all comments and replies, and this 24941 should hopefully be very close to the official count provided by YouTube. Let's have a look. So we have 24962. The variance is only 1 record, which is good. And this gives us some assurance about the quality of our data. Now we can use Pandas DataFrame to look at the data we downloaded from YouTube API. We can think of Pandas DataFrame as Microsoft Excel in Python. Here we use the DataFrame function from the Pandas library, and we first load the top-level comments into the data frame. We then load the video ID, Google account ID, and comment ID into the same data frame. Then we do a bit of reordering of the columns. For the data of replies, the concept is the same. We just need to add one extra column for the parent ID of associated top-level comments. Again, we would do the reordering of columns in the data frame for replies data. If we run this line, we will get a nice display of data for top-level comments. Similarly, this line is for a quick display of data for the replies to top-level comments. Lastly, we can check and see if we have any missing Google account IDs. Remember, our program would replace missing values with no entry. Here, these two queries would return any data with Google account ID equal to no entry. As we can see, there's no missing value for Google account ID in our case. Alright, we have covered pretty much everything we need to know about downloading YouTube comments and replies from YouTube Data API.
Some may ask why this video is even relevant to data science.
First of all, it allows us to get some practical experience working with API.
Data practitioners are expected to know how to handle different sources of data.
Secondly, it allows us to work with JSON, which is an important and commonly used data format. Thirdly, we have an excellent opportunity to practice using two different loops in the Python language, the for loop and the while loop. Loops are usually required in a program if the problem we are trying to tackle is not something that can be easily solved. Finally, if you want a little fun exercise, please consider enhancing the program in this video and wrapping it into a Python function. I will paste the link to this Colab workbook in the description below. If you find this video helpful, please like and subscribe, and I will see you in the next one.